Now let's come to the second quadrant where you apply the supervised machine learning algorithm on the unstructured data. As I said, in supervised machine learning algorithms, we have the target variable that we have to predict, but the data here is unstructured. When it is unstructured data, the data is not in the form of CSV file, nor even an Excel sheet, nor even in a database. It is simple free-flowing data, like the data in our emails. It can even be the data of the songs that you are playing, or it can be the voice call that you are making to your friend on your phone. All the data that is a free-flowing data. But from this data too, we can actually derive insights. That is the beauty of machine learning algorithms. We need not have data that is stored. We can even have stored data where you apply the ML algorithms. But it can be free-flowing data that way you can use ML on top of it. Now, for the sake of simplicity, let's take a simple example. One is a sentiment analysis. Sentiment analysis. What is sentiment analysis? Where our ML algorithm can understand the text that is there and can give us an insight if the text is a positive sentiment or a neutral sentiment or a bad sentiment, that is negative sentiment. If suppose you say the movie was great and you have written a paragraph on the movie, it can be a positive sentiment, right? We as human beings will understand if it is a positive or a negative. But it may not be possible for us to sit and understand the text every time, each and every time. So we apply ML algorithms where there could be millions of pages which have to be read and understood, and the sentiment has to be understood. Or it can be negative sentiment also. Sometimes it can be partial. So there can be some words which are on the positive side. There can be some words which are on the negative side. And in such cases, ML has built-in algorithm which can understand the mode, that is how many positive words are there and the words associated with the other words. Based on that, the ML algorithms, that is the NLP, natural language processing, is the algorithm that I used here. It can understand how sentimentally positive is that particular text. The standard example we hear on sentiment analysis is on the tweets. How is the sentiment analysis on the tweets that are produced because of demonetization? Probably negative. But how about the sentiment analysis about something that has greatly happened? It will be positive, right? We as human beings would understand it could be positive. But it doesn't mean that it is always positive. There can be scenarios where in real time many people may be thinking that it's a good thing. But in the digital area or the digital presence, the tweets that are produced may be on the negative side. In such scenarios, obviously our ML algorithm will only take the data that is given as input. So the input data that is given to our machine learning algorithm has to be more relevant. This shows that the more relevant and the more high the amount of data that we give as input to our ML algorithm, the better output we get. Let's take a simple example. If you come out of a movie and someone asks, how was the movie? You would probably give your opinion, whether it's good or bad. But in a second scenario where you had a great expectation of the movie and with great struggle you got the movie ticket, you went for the movie, paying very high price to it, came out, and then you were disappointed. But if someone asks you, how was the movie? What would you say? Your immediate reaction would be sarcastically saying that, wow, the movie was great. But the follow-up words would be negative, right? If our ML algorithm only takes the words in your first sentence, which you say, it is great, but you know what? I did not enjoy the movie. The second sentence is that, right? A friend of yours who hears you speaking understands that you are not happy about the movie. In a similar fashion, our ML algorithm also does it. Though the first sentence of your reaction after watching the movie was, it is great. It even understands or digests the text that was followed up, and it understands your actual feeling for the movie, whether it's positive, negative, or neutral, based on the words that you have used. It will probably take the mode, that is the more number of positive words you have said, along with what other words you have used. There is something called stop words which are removed, something called pauses, even that will be removed. So everything is inbuilt in the algorithms, and the beauty of ML again is these algorithms are very complicated or already built in. They are not built in, they are already written. So data scientists have to understand it and use it as per the business requirement. Now let's come to the spam detection. Each of you have these mails, right? Gmail. You see that many of your mails directly get into non-genuine mail. Many of it will actually fall into the inbox, but some of them go to spam, non-genuine is spam. Though you haven't voluntarily taken any action for them to be dropped into spam mails, right? Because the machine learning algorithm behind is understanding the data. That is, what is the data here? Data, the text in the mail. It is reading the text and is able to predict that it's a spam. It's a spam. Sometimes very little chances, there are chances that your genuine mail also drops in the spam. That's the reason we have to check in the spam folder too if there is any mail. That is again because all the machine learning algorithms cannot be 100% accurate the first time you build them. That's a different topic. But again, spam detection is a supervised machine learning algorithm. The algorithms that are used to build spam detection use the supervised machine learning algorithms or use the unstructured data. Unstructured data because all the data in our emails is in the free-flowing text format, which is in the unstructured data. The third example is predicting cancer. Cancer can be predicted by analyzing the images of the tumors. What is tumor image? What is an image? Image is again unstructured data. How can we have to apply deep learning. Deep learning is again advanced machine learning, which when applied on these images, which is in unstructured format, can actually predict if the tumor is malignant or benign. What are the two options we have? We have malignant or benign. So it comes under supervised because the target variable has predefined values, benign and malignant. But the data is unstructured. So this comes under this quadrant where you have applied supervised machine learning algorithm on unstructured data.